Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP Route course, and we're going to be taking a look in this video tutorial at Discovery Activity 7. Again, very thrilled with these activities as they reinforce a lot of the material that we've been looking at so far throughout the semester. So let's go ahead and jump in here. We're going to be doing EIGRP for IPv6. Now, to be clear, remember that EIGRP named mode is different than EIGRP for IPv6 because EIGRP for IPv6 is still using the 32-bit metrics, whereas the EIGRP named mode is using the 64-bit metrics, and we'll take a look at how we can see whether or not that's the case, so we can differentiate between the two. So it's asking us on branch 2 to go ahead and configure EIGRP. So let's go from user exec to privilege exec and into global config. Now, if I were to say we'll say IPv6 router, I'm going to skip that step because we want to make sure we see the error here. IPv6 router EIGRP 100, you can see, and that's the error I wanted you to see. IPv6 routing not enabled. So what we want to do from this point is what they have up there in step 1, which is we need to make sure we enable IPv6 unicast-routing, right? So now once we have that turned on, then we can go ahead and fire up our IPv6 router EIGRP 100 command. So before we do anything else, it's always a good idea to do a do show run. Oops, sorry about that. Let's get that RUN section EIGRP in there. And what we're looking for specifically is the shutdown command. Because on releases, and it's documented that it said, anything after 15.x, that it is not shut down by default. However, you'll still find in some of the older 15 code, some of the first releases that came out, that sometimes it does end up as being shut down. In fact, if we take a look here, and I'm looking for router 5, and there it is. So router 5 is actually running show version, I believe 12.4. Yeah, so router 5 is running 12.4 code, show run section EIGRP. And let's see what we've got here. So not much. So if I go into global config here, and I say, let's see if we get that same error message, router, actually let's do IPv6, router EIGRP 100. You can see IPv6 routing is not enabled, so I want to come back with IPv6 unicast routing and enable IPv6 unicast routing, and then I can say IPv6 router EIGRP 100. If I say do show run section EIGRP in the 12.4 code, and I'm glad that it cooperated. I'm also glad that I typically always keep one router with 12 code on it, just so you can see what used to happen, because you may see this either on the exams or in the real world when you're working in your environment. For whatever reason, you fire up EIGRP for IPv6 and it doesn't establish the adjacency. You can see here it's automatically shut down. So how do we deal with that? If I say no shut, then that solves the problem. So if we do the do show run section EIGRP, you can see that it will actually say no shutdown. So again, this is an important point because not only is it affecting 12 code, but it did on some very early 15 code, it would leave it shut down, even though it was documented that all 15 code that it shouldn't have been doing that. You still found sort of here and there you would find where it would still be shut down. So definitely something to be aware of. All right, so now what we're going to do, it's asking us to configure the router ID. Now it looks like we spend the majority of our time here on branch 2. I'm going to take a look at the headquarters router, and let's see if I do a show run section EIGRP. I'm hoping that this is already set up, and it is. So you can see that the EIGRP is already set up. You can also see that the router ID is 192.168.0.1. So I'm going to make a quick note of that over here. I'm going to say 192.168.0.1. And again, this is a great place. These labs are absolutely fantastic sandboxes for you to go ahead and experiment with different things, to check some different things out. So here's one of the things that we're going to check out. If I go back to branch 2, now it says we do the IPv6 router EIGRP 100. We did. We can see that the process is not shut down. And if I were to say EIGRP router ID 192.168, whoops, 168 dot, and I unfortunately cleared that away, but it was .0.1. So I'm going to use the exact same router ID that is set on the HQ router. And let's see if duplicate router IDs will prevent the adjacency from coming up. So we've got it set. We haven't seen anything yet. And, oh, I'm sorry. I looked down at step 3 here. Thought we were already fully configured. So yeah, so I got to jump down to the interface actually, Ethernet 00, and we have to put in here IPv6 EIGRP 100, and we're going to do the same thing on, and there you go. Our adjacency is established. And on the loopback interface loopback 0, we're going to say IPv6 EIGRP 100. All right. So as you can see, the adjacency does come up. Do show IPv6 EIGRP Neighbor. And there we go. And again, to kind of reinforce the fields that we're seeing here, this H, I always want to say hold. I don't know why, but it doesn't stand for hold. It stands for handle. And all it means is the order in which the neighbors are discovered, and it starts at 0. And this 5 is, I think, stretching around from the sequence number. This is a little, yeah, the sequence number. This kind of got broken apart here. But at the end down here is where you would typically see sequence number. And it's simply just the number, the sequence number of the last packet that was received. So let's talk about some of these other fields. So we've got the 0, which is our handle, indicating that this is the first neighbor that was learned. And out which interface, out which local interface. So on the branch 2 router, out Ethernet 00 is where this neighbor was learned. The hold time, we just happen to catch it right down at 10 seconds, and it should not drop below 10. If it does, we probably have an issue. The uptime, so how long has this adjacency been up? It's been up for 20 seconds. The smooth round trip time, and this is how long it takes a packet to go to the neighbor and make its way back to the originating router. So in our case, branch 2. Now, the smooth round trip time is typically 6 times the retransmission timeout, which is that number right there. Typically, you're going to see that if you multiply the SRTT, smooth round trip time, by 6, you end up with the retransmission timeout. And this is how long in milliseconds that the router will wait before it requests a resend, right? And then the queue count is 0, and we want to make sure that the queue count is always 0. If you see things queuing up, it could be some latency, some congestion, or it could be something bigger. So make sure that you always check that out. All right, well, let's clear the screen here. And I'm actually going to pull back. Let's pull this window back. So if I were to say, and I don't believe I have any neighbors on any of these routers. Give me a second here. I had another window. Here we go. And I believe we do have some IPv6 neighbors here. So if I said do show IPv6 EIGRP neighbors. No, we don't have neighbors there. Let's check over here. Do show, whoops. So do show IPv6 EIGRP neighbors. And none. So yeah, we don't. Unfortunately, I had some IPv6 set up earlier, but not right now. I was going to try to get this output to display on the screen just a little bit cleaner. Okay, so we've taken a look at the neighbors. Now remember, one of the critical points with EIGRP for IPv6, all right, remember this is not named mode, is that when we go to enable EIGRP on an interface, it is done under the interface. And we haven't talked about OSPF yet. When we do, you'll see that we do the exact same thing with OSPF. For IPv4 and IPv6, we're going to come under the interface and we're going to give the IPv6 the name of the protocol. We're using EIGRP and the autonomous system number. And this is how we start it up under the interface. Again, if I were to come back over to the command line here on branch 2 and say IPv6 router EIGRP 100 and do a question mark, do you see the network command anywhere? And the answer is no. The network command is no longer there. And so with EIGRP for IPv6, the only way to enable IPv6, EIGRP for IPv6 on an interface is under the interface configuration mode, right? All right, so that adjacency came up. We did it with the same router ID, so do show run section EIGRP. So let's go ahead and fix that. So I'm going to say no EIGRP router ID 192.168.0.1. And again, the router ID is going to be retained until we restart the process. We'll do that here in a second. And let me confirm. Okay, good. So let's add in EIGRP, whoops, pull it back here, router ID 192.168.2.1. Now, and the reason I wanted to show you the matching of the router IDs is because in OSPF, you can get yourself into quite a bit of trouble if the router IDs are the same, right? You'll definitely have challenges with adjacencies. And so you may see at some point in your studies questions along the line of, do the router IDs need to match for an OSPF adjacency to establish? And the answer is no, they do not, and we just saw that right here. Okay, so we'll continue down here. Where are we at? Okay, so we're going to verify the neighbors. We just took a look at the neighbors, right? So let's go ahead on branch 2 and take a look at our topology. So do show IPv6 EIGRP topo. And here is our EIGRP topology table for IPv6. And again, there should be nothing new here, right? Except for we've got IPv6 addresses. However, that is still my successor route, right? We have a single successor. Everybody should be very comfortable with the feasible distance. And here is the via. So that is my successor. And he is the next hop who I will be going through to reach my destination, and it will be out my Ethernet 00 interface. Now again, let's remember that that number right there is not the feasible distance. So again, we're stepping it up into the CCNP realm here, and so this is the computed distance. And the key thing to remember is my feasible distance is here, my computed distance is here. Now, the very first time that these transition, or that this successor route transitions from active to passive, right? So it means that it went active, the finite state machine had to do its calculation on the metrics for this route, for this successor route. It went from active, having the calculations run, to passive, where it was declared loop free, right? And these values at that point in time were the same. However, as we saw in a preceding video, this value, the computed distance, can and does change. And so it will show a different value sometimes than the feasible distance. And remember, the feasible distance is a static point in time snapshot of this route's metric the last time it transitioned from an active state to a passive state. All right? And so again, remember that this is a static value and it will not change until the next time this successor route goes into the active state and then transitions into the passive state again. Okay? So again, key values here to remember, and this is my reported, move it a little further over here, that is my reported distance, right? And the reason that this is important is you will also see it referred to as the advertised, I'll just put advertised distance. And the reason you typically don't see, this is RD, and this will be referred to as AD. And that is one of the reasons why I don't really like using the reported distance, because this is too easily confused with what? Exactly, administrative distance. Now, obviously, there are no routing protocols that have administrative distances that are this high. However, just seeing the AD, it's not really clear all the time as you're reading. So I always like to stick with RD for reported distance, but this is the reported distance. And the key, if we had any feasible successors here, is to remember that in order to become a feasible successor, you have to satisfy two conditions. The first is loop freedom, and that is only satisfied if and only if the reported distance of the candidate to become a feasible successor is less than the feasible distance of the current successor. Because what that means is that the candidate to become the feasible successor is saying my reported distance to the destination network is less than yours, Mr. Feasible or Mr. Successor. Therefore, I am closer than you, which guarantees that I am mathematically not going through you to get to the destination. Okay? All right. So we'll clear the screen there. A good talk about the IPv6. And again, you'll notice that a lot of the commands with EIGRP for IPv6 have been conveniently left the same. And I mean, really, if you think about it, the only thing you're changing in these commands, right, there's the all links option. If I were to say do show IP EIGRP, or actually do show IPv6, the only difference is you're putting IPv6 instead of IP. So when I say do show IPv6 EIGRP neighbors, right? There's the neighbors command. Let's do a, actually we're in the config mode there. So we looked at the topology table. Do show IPv6 EIGRP. Oh, let's see, what else can we look at here? Let me bail out of this mode here and say show IPv6 EIGRP and do a question mark. Not a whole lot to look at. We could look at events, right? So here are some of the events where we see the updates being sent, the updates being received. And very interesting here, remember when we talk about EIGRP for IPv6 as well as IPv4, poison squashed. What do you think that means? So route network gone for 201 db8 03:/64. So poison squash, could it have anything to do with poison reverse? So it's 2001 db8, where did it go? There it is. 2001 db8 0:3, and where is that at? 2001 db8, here it is right here. 2001 db8 0:3/64. Well, that's a loopback address over here on branch 1. So if branch 2 is learning about that route from the headquarters router, and let's take a look into the branch 2 routing table, which is actually what they're asking us to do next. So show IPv6 route. And so here are the routes. So if I'm learning about the db8 0:3:/64, if I'm learning about that route from who? the HQ router on my Ethernet 00 interface. So here is my routing table entry, and there's no coincidence that we say poison squash, right? So remember, split horizon, and if we take a look here, if I were to say show IPv6 protocols, you can see that we've got our listing here for EIGRP, and actually I'm looking for show IPv6 EIGRP, and I want to see 100, and I shouldn't even need to see that. I'm looking for, where is it going to be at? Is it, and actually maybe it's interfaces detail, I believe. Yeah, there we go. Sorry, I'd drawn a blank there for a second. So split horizon is enabled, right? So remember that EIGRP by default employs split horizon and poison reverse. Okay? So split horizon is enabled as well as poison reverse, as we saw when we took a look at the show IPv6 EIGRP events. And we end up with, let me go ahead and keep scrolling down here, and we end up with, and did I scroll right, whoops, did I scroll by it accidentally? Let's scroll up a little bit here. You can see where it was finding the feasible successor. The route's been installed. We've got our updates, and where is our poison entry? And again, I apologize if I ran by it earlier. Let's see here. I definitely went way too far past. All right, well, we saw it earlier, and I apologize. I'm trying to remember how much output we had here. All right, so we'll move on. So again, if you look at the events, you can see additional little details, and right here you can see that we had an update reason and the delay metric change, right? So you can see update sent, reported distance, route installed. So let's go ahead and take a look at the topology table again. So show IPv6 EIGRP topology, and there's the routing table. I'm just looking to see if I can catch any of the, yeah, we don't have any of the changes in there that I was hoping for. Okay. So we're going to go ahead and move on now. We took a look at the show IPv6 route. So let's go ahead now and actually, excuse me, I'm going to get grab a quick drink here. Just stand by for 1 sec. All right, sorry about that little break there. All right, so we finished up step 6 where we were talking about taking a look at the routing table. So if I were to say show IPv6 route EIGRP, whoops, EIGRP. So there's our routing table, and they're interested in having us take a look at the successor route that got installed over to DB8 2001 DB8:0:1, which is this one right here, right? And let me see what they're talking about here. So you can still see the administrative distance, even though it's EIGRP for IPv6, the administrative distance is going to stay 90. And even when we look at named mode, the administrative distance of the protocol does not change, right? So, and let me clarify that statement. So for internal routes, and this is an internal EIGRP route, it's in the same AS, it's going to be 90. If we had an external route, maybe we redistributed a static route, it would have an administrative distance of 170. So the internal, right, and I'll say the intra-AS routes for EIGRP are more preferred than the external routes for EIGRP. And when we get into OSPF this coming week, we're going to have all kinds of fun with intra-area, inter-area, E1, E2, N1, N2, and we'll get to talk about how OSPF makes its decisions with respect to which routes it's going to prefer. All right, so let me go ahead and we'll clear the screen here. In fact, if I were to, we were taking a look at the topology table on BR 2, and I was saying show IPv6 EIGRP topo, and I was looking to see if any of those values had changed. So let's do this. If I come over to the HQ router here, and this should, let me take a look at the diagram real quick. This should Ethernet 01. If I go into global config and go into interface Ethernet 01, if I were to say do show int Ethernet 01, and we see that the delay is 1,000 microseconds right here, that's our delay is 1,000 microseconds. So if it's in tens of microseconds, when we put a value in, we just divide that number by 10, so it would be 100. So if I were to come over and tweak that value by saying delay, let's see if we don't do it too much. If I tweak it to say delay 101, and then take a look at, see if we have any difference here in the topology table for any of the routes, and let me see if I can make it a little larger. Or let's actually, I'm on the wrong interface, so I can actually do this from BR2's perspective, Ethernet 00. Interface Ethernet 00, and go into global config first, and go into interface Ethernet 00 and say delay, and let's make it 150 and see if we see anything different now in the do show IPv6 EIGRP topo, and it doesn't look like that has manipulated or moved the meter. Oh wait, you know why? Hold on one second here. So if I go delay, throughput and delay in tens of microseconds. So I'm trying not to force it into the active state because I don't want it to recompute. And the outgoing is going to be, let's do this. Let's put in here 4,000. That may be too big. So I'm trying to think of a decent value. Let me drop it. Let me see if I can drop it down to delay 2 if we have any success. Aha, perfect. All right. So there we go. Was going the wrong direction with the delay. So as you can see, here is the computed distance. And what do you see about the computed distance as compared to the feasible distance? That this value has changed. This value is still static from what it was from the last time this successor route went from active to passive. So if I clear the screen and I say do clear IP EIGRP Neighbor soft. So EIGRP should do a soft reconfiguration, and when I say do show IP EIGRP, or actually I'm sorry, IPv6 is what we want to clear. I'm so used to dealing with v4, so IPv6, and there we go. I was waiting for that to pop up and it did not pop up. So we've got the resync there. So now when I come back and say do show IPv6 EIGRP topology, things have now recalculated and we have new values. And again, they match because it just went from active to passive. So the computed distance here and the feasible distance here are the same. However, we've seen where when we manipulate the delay, these values will change. So I'm still in the interface, so if I say no delay 2, is that going to show any type of change? No, actually, because it configured it, or didn't configure it, it calculated it. So no, we're going to be stuck with the same values there. All right, so let's go ahead and move on, and we'll wrap up Discovery 7 here. So it wants us to go ahead and issue a ping command from the BR2 LAN interface to the BR1 LAN interface. So we're going to go ahead and I'll say end, and we'll say ping 2001 colon db8 colon 0 colon 1 colon 1 or colon 1. And let me source that from our loopback 0 address. All right, and we've got full reachability. So now what we're going to do is we're going to talk about, we've already talked about summarization with IPv4, So now we're going to do some summarization with IPv6, and this is going to be on the branch 1 router. Before we get there, though, this is a great opportunity to take a look at the address range that we're going to summarize here. So we've got 2001 DB8 :0:0//64. So we need to figure out where is the interesting hextet, right? Well, that is our interesting hextet. So again, the steps are similar to IPv4. We, one, identify the interesting hextet, right? So now what's critical here is the rule of zeros is in play with this IPv6 address, where we have :0:0 or :1, right? Or :2. Now, the key thing to remember is step 2 is going to be that we write out these hexadecimal characters, but we need all 4 that are in that range. So step 2, I'm going to say 0000, and then the 1 would be 0001, because remember, the rules of 1 is in play where we're actually dropping the leading zeros in each of these hextets. So there's not just a 2 in that hextet, it's actually 0002. So now that we have the hexadecimal values, we're going to change the color here of our pin to blue, and I'm going to do the decimal values. So 0 in hexadecimal is equivalent to, I'm going to give you the binary values, it is the equivalent to 0000. And so I won't write out all the zeros for all these zeros here, but we're now down to sort of the bit boundary here where that's 0000. 1 in binary is going to be 0001, and 2 in binary is 0010. So now we'll do one last color change here, and we'll go to black, because now at the bit boundary we can see that the first, or actually I apologize, let me pull that line back. We can see that, start from the bottom here, that they no longer match right there, right? So it's a little messy here, but what we know is in this hextet of 16 bits, we have 4 bits that match here. Remember, these are 4 zeros, or 4 binary zeros. We've got another 4 bits, because we're talking about binary. 4 more bits, another 4 bits that match here. So a total of 12. But then we've got 13, 14, right? So a total of 14 additional bits that match for us. Well, when we take a look over here, actually go a little further, over here, we know we've got 16 and 16 and 16 that already match. So 16 times 3 is 48. 48 plus plus 64. 48 plus 14 is 62. So we should have 62 bits in common. If we look down here, you got it. So and it's not a subnet mask. Another key point to remember, right? This is a prefix length. There are no more subnet masks in IPv6. So we're talking about a prefix length of 62. And so then the last thing we need to do is kind of put this all back together again, where we've got 2001 :DB8 :0. Now, here's where we hit our interesting octet. So we had 0, 1, and 2. Well, when we worked this out, we had all zeros that matched throughout, right? All of our matching bits, we never had a bit position on, which means it would be 0:0:0 /62. And does that match up? Yep, and it matches up with what we have there. So again, another great opportunity to sort of exercise your IPv6 summary address skills, because if you see something like this on the exam, it's going to be critical that that you're able to do it quickly and confidently, so that you feel like you're coming out with the correct answer. All right, so we're going to go ahead now and apply this summary. And I'll leave that up there. So we're going to go over to branch 1 is where the summary is going to get applied. So we'll go from user exec to privilege exec into global config. And we're going to apply the summary on the interface Ethernet 00. All right, so we're going to say IPv6, summary address, EIGRP 100, and what's our summary? And I really like how it does this here, right? It kind of prompts you up and says this is the format that I want to see the address in. So we're going to go 2001:db8:0:0:/62, and let me confirm that that is what we've got there. 2001 db8:0:0:0:/62. All right, so we have our summary address here. When we hit enter, it's critical to remember that this is going to do a graceful resync. It is not a tearing down of the adjacency, right? So the adjacency did not get torn down. If I come over to HQ, you'll see there we have the pure graceful restart. So it's just a resyncing of the routing information. So if on the HQ router I say do show IPv6 route EIGRP, what do we see now? We see, and let me change that from black. That is not going to work. Go with, and yellow is probably not going to be the best choice either. So red. So what do we see here? We've got this route here, which is the 0:16. I'd actually have to go back and look. I'm not sure where that's at, although it's probably coming off of branch 2, if I'm not mistaken. I think the HQ Ethernet 01 goes to branch 2 or towards branch 2. And then here, and it must, yeah, so Ethernet 01. So this is coming from branch 2, who we were working on earlier. This is being learned from branch 1, and we know that because here is our summary, right? This is our successor route right here. Here's our administrative distance for EIGRP of 90. Here is my computed distance, 409,600. And again, we've got our /62.